Good afternoon, class. Today we are going to practice pairing ions together into their formulas, as well as a little bit of nomenclature. We're going to be using some polyatomic ions today. Poly meaning multiple atoms. So a polyatomic ion is an ion formed of multiple atoms. The first one that we're going to look at is the lithium ion. And we are going to pair that with a sulfate ion. So first, where does lithium fall in the periodic table? Well, if we take a look, we see that lithium is in group 1, so it has a charge of +1. So we draw our little lithium ion with one arm. It's a +1, it has one arm. Sulfate is one of the common polyatomic ions. It's one of the ones that you should know for this class. Sulfate is a polyatomic ion with the format SO4 2-. So we draw our little ion here with our circle around it, and it has a 2-, so it has two arms. 2-, 2 arms. So we connect our lithium to our sulfate, and we see that the sulfate has one arm left over, so it needs a second lithium ion. Let's add another lithium ion here with its one arm, connect those two. So the formula to pair a lithium ion and a sulfate ion is Li2SO4. Now how do we name this? Just like before, we have an ionic compound with a non-transition metal, so we're just going to name it lithium. No Roman numeral needed because it's not a transition metal. So we have lithium. Now, we don't need to change the ending of anything here to "ide." Polyatomic ions are special in that they've already been given a name. So we do not need to change the name from sulfate to sulfide, right? Because sulfide would indicate a sulfur anion. This is sulfate. So the name of this compound is lithium sulfate. Let's try another one. We're going to pair a magnesium ion with a chlorate ion. If we take a look at the periodic table, magnesium is a +2, so we draw our little ion here with its two arms. Okay? And a chlorate ion, if you look at your table of common polyatomic ions, is ClO3-1. So we draw our little ion here with one arm, -1, one arm. So now if we connect our magnesium to our chlorate, we see that we have one arm left over for the magnesium. So we need another chlorate, ClO3-. Draw a little circle here, or a little one arm, and our connection. So the formula for this guy is Mg, and we have two ClO3s. So let me just put a 2 there. How's that look? I'm noticing something, huh? Doesn't this look like 32 oxygens, not 2 chlorates? So how can we fix that? Well, let's put a set of parentheses around the ClO3. Now we can see that there are 2 of that whole ion. So Mg parentheses ClO3 close parentheses 2. Now how do we name this? Again, just like before, we don't change the name of the metal. So we have magnesium. Okay. This is a polyatomic ion, so we don't need to change its name. We have magnesium and chlorate. Magnesium chlorate. Okay, we're going to pair a copper ion and a phosphate ion. So if you look on the periodic table, you'll see that copper is a transition metal. Copper can form 2 ions. It could form a +1 or a +2. So let's look at +1 first. We'll do a Cu +1, which means one arm. And phosphate. Phosphate is PO4 with a 3-. So it has 3 arms, 1, 2, 3. Connect our copper. We can see that we need another copper. One arm. And clearly we can see we need a third. So our formula for this is Cu3 PO4. Notice that we don't need parentheses around this because there's only one PO4. So Cu3PO4. Now, what if we had our copper 2 plus? Copper plus 2. Now it's got 2 arms. And so we have a PO4 3 minus with 3 arms. Connect, connect. Okay. We've run out of positive charges to work with our negatives, so clearly we need another copper. Another plus 2 with 2 arms. 1 connects. Now we've run out of negatives, so we need a PO4 3 minus here. 1, 2, 3 arms. And we've run out of positives, so we need another copper here with 2 arms. And we're done. So our formula for this guy is Cu3PO4 with 2. So what do? If we name both of these copper phosphate, how will we tell the difference between the two? So just like we learned in lecture, when we have a transition metal, we are going to tell the person coming after us the charge on the ion, so they know what ratio to put them together in. So for the first one, we have what charge on the copper? We have a positive 1, so it is copper 1 phosphate. Okay. And for the second one, we have copper, and now we have a plus 2 on there, so it's copper 2 phosphate. So again, just like I said in lecture, and I'm going to say it again, the charge on the ion is indicated by the Roman numeral. The Roman numeral has nothing to do with how many of anything are present in the molecule. Okay, the charge the Roman numeral rather, simply tells you the charge on the ion that you're looking at. So let's try one more. Let's erase this copper 2 down here so we can do one more. Okay, here we go. All right, one more. It says pair an ammonium ion and a nitrate ion. So ammonium ions are kind of funny. They're one of the few that have a positive charge as far as polyatomics go. It is NH4 plus. And then we have a nitrate ion, which is NO3 minus. So let's draw our little ions here with our little arms. NH4 plus has 1 arm. NO3 minus has 1 arm. So we can connect those two. So we have 1 NH4 and 1 NO3. So the formula is just NH4NO3. Name, if you have 2 polyatomics that are paired together, it is simply the name of each. So it is ammonium nitrate. Nice and easy, right? No Roman numerals to worry about. No endings to change. You literally just take the name of the first one and the name of the second one, and that is the name of your compound. Thank you so much for listening.